Hello, my name is Ray Walsh, founder of Deep Blue Shipping. I've spent over 20 years in tanker ship operations. Simply put, my job was to make sure that ships move efficiently around the globe. Throughout my 20-year career, I've always been frustrated by just how outdated and manual the processes that we use are. Our systems are fragmented and our workflows can be quite inefficient. This can lead to delayed deliveries, increased costs, unnecessary increase in emissions, and ultimately an increase in operational risk. A simple fact in my industry is the average tanker ship owner owns 2.4 ships. What this means is in their offices, a lot of their operational staff are wearing many hats and buttering the bread a little bit too thin. A lot of the operational tasks that they perform can be quite fragmented, quite archaic in the systems that they use. For example, what we're looking at today, Laytime calculations. These are still handled largely in spreadsheets, bringing together PDFs and emails and other disconnected tools. It makes the task cumbersome, laborious, and so prone to inaccuracy. Because of this, revenues can be missed, and I think more importantly, learning opportunities are missed, which can lead to efficiencies in operating the ships. That's why I founded Deep Blue Shipping. I knew that technologies existed that we should be harnessing to make our job better. Automations, AIs, machine learning, all of these things can revolutionise my industry, make the job less cumbersome, and massively improve the efficiencies of what we do.
Okay, so let's dive into what Deep Blue has been building so far. We will open here on the deepblueshipping.com webpage because that's what the YouTube clip told me I should do. So if you have any questions about who we are and what we've been doing, please do go to deepblueshipping.com. To dive into our software that we have developed so far. So what you are looking at is the prototype, and we are currently in the process of building our MVP. Once the MVP is up, we'll start moving on to the more complicated plugins that we want to build into it. So how we're going to look at things is we look at claims of time, so laytime and demurrage. Laytime is a calculation of the time that a ship uses import, and demurrage is the name of the liquid damage that occurs if too much time is spent in port. So we break these down into individual claims per ship and each contract that a ship is under. So we want to build a kind of simple, almost like a CRM type of tool here where we can break down each of the claims, and it's just a simple ledger really at this point. And then this is where we start to get a bit clever. So what we want to do is we want to look at the claims fully as a voyage. So we can take here the TRF Kristianstad and we can start building the claim per ports. So we'll do a nice simple 2-port calculation of a ship going from Rotterdam, and let's call this, where should we send it to? Hamburg. And let's assume that the ship is taking 50,000 tonnes of fuel oil. So we have the ports here, and you can see here that we're already starting to build a calculation of the time. So we're looking at how much time that this ship is allowed, basis the calculation, and what the demurrage, the liquid damage, will be, basis this. Now we can start looking at the time individually for each port. So we'll start building our events. Notice a readiness tendered is when we tend to commence. And hose disconnected is when we tend to complete. Let's assume this is a one day port stay. We can see here that the time allowed is 333 hours, time used is 24. And then let's have a look at Hamburg. And then let's just assume that happened yesterday and completed today. As we can see here that there's a lot of time allowed, so let's reduce this allowance. So we're going to assume that we only carried 2,000 tons of cargo, and we can see here that the system has calculated everything for us already, and we have a liquid damage cost here of $13,000. From here we can quickly generate a report which will be a summary of the case, and we can print that and send that out. Now that's the simple system as it looks today. What we want to do as the next stage is these events. We want to start plugging these into the data that is generated as it is generated. So generally, as a ship transits through a port, it tracks its events on board the ship. We're working with ship owners to actually have a simple version of this sitting on board the ship, and it will send the data straight to our system. So there will be no need for the human to actually enter this data into our system here. And then deductions here, we can actually make deductions. Let's assume for shifting from anchorage here, we could look at, this happened on the 17th over the space of 1 hour. And we get a 1 hour deduction. One of the ways that we want to really drive this forward is all of these voyages will be based on an individual contract, what we call a charter party. And what we want to be doing is using large language models to read those contracts and extract the clauses that create deductions in these time calculations. So we want to take that unstructured data of a contract. We want to use our large language models to structure that and then allow this system to access that structured data and automatically make these deductions without the necessity of the human. Now, the average industry standard of getting these calculations accurate is around 92%. So we know that if we can get routines, based on these extractions from the contracts at above a 92%, we will then be better in what a human can do, and we can really drive this product forward and eliminate a lot of the human data entry that's required to do this. Some of these calculations can be over multiple ports, multiple berths, and can take several hours of data entry and checking documents to get them right. So that's it in a nutshell as it looks today. If you've got any questions, you can email me at ray@deepblueshipping.com, or please do go to our website, deepblueshipping.com. Thank you.